There are some potential pitfalls that you need to be aware of when it comes to working with inequalities and solving one variable inequalities. This example here should look familiar. We did this example in a previous video. And in that video, I made the decision to move the variable to the left-hand side. I added 14v to both sides. But what if I had gone the other way? What if I had decided that the variable needed to be on the right instead of on the left? In that situation, I was going to end up with the problem that we see highlighted here. When we multiply or divide both sides of an inequality by a negative, we must reverse the inequality symbol. You probably have some experience with this rule in the past, but it's worth reminding ourselves how that rule actually affects the solving that we're going to do. So as I suggested, let's try this example again, but this time we're going to go the other direction. And I'm going to move the 6v over to the right. When I move the 6v over to the right, I end up with the 8, and I end up with negative 8v minus 28. Still solving, I'm going to add 28 over to the 36, and I get 36 is greater than, I'm going to add the 28 over to the 8, get 36. I'm going to end up with 36 is greater than negative 8v. I'm going to finish by dividing by 8. Now, if we keep track of that rule here, that's what we're doing right now. We are dividing by a negative number, which means that when I write my solution, I need to face the inequality the other direction. 36 divided by 8 is still 4.5, so in this case, we'll get negative 4.5. I'll flip the inequality, face it the other direction, and have it open towards the v. Before you think to yourself that that's a different answer than the question that we did before, if you go back and review the question that we did before, you'll see that we got the same answer. It's simply just facing in the other direction. It's still v is greater than negative 4.5, and that only happened because we made that decision to switch the inequality based on that negative. The graph looks exactly the same. In an example like the one you see here, you're going to have to fight the urge to use cross multiplication. Cross multiplication is a very common strategy when it comes to solving a proportion where a fraction is equal to another fraction, but it's a lot more challenging to use when we have an inequality involved. There are ways to do it, but it's advised that you just don't. The truth is that it gets too bogged down in deciding which way to face the inequality symbol, that it's a lot easier to instead just use multiplication by common denominators. If you look at the two fractions that are here, you'll see that the two denominators, 5 and 4, have a lowest common denominator of 20. This is going to serve the same purpose of cross multiplication, but without the circles being drawn and without you having to worry about which way to face the inequality. 20 simplifies with the 5 to leave behind a 4. So the left-hand side becomes 4, 9z minus 4. And the right side, the 4, simplifies with the 20 to leave a 5. And we're left with 5 times 7z plus 2. Yes, it looks like cross multiplication. It looks like the 5 times 7z plus 2 and the 4 times 9z minus 4. But the truth is that we didn't have to worry about the inequality symbol. We just placed it in between the two distributions, and now we have exactly the way it's going to go. If you happen to multiply in a different direction, you might have put one of them on the left and one of them on the other one on the left and messed up the order. We don't want that to happen. So if we just use common denominators as the multiplication, that's going to be a lot easier. 36z minus 16 less than or equal to 35z plus 10. Subtract 35z from both sides, add the 16 over, and we get z is less than or equal to 26. Same goes for our number lines here. Here's 26. We're going to fill in this circle because we are equal to. We never divided by a negative. Sure, we had negative numbers, but we never multiplied or divided by a negative. So we're going to stay in the same direction, shading to the left, less than 26. You might remember from previous lessons that there were equations that did not have solutions or had an infinite number of solutions. Well, it's a little bit trickier here because technically all of these inequalities all had an infinite number of solutions. Remember, you're just looking for something that falls into a particular range. So we can't just throw out that these ones are going to have infinite solutions as well. But some of these might have infinite solutions for a different reason, or no solution for a different reason. And we want to be observant of those circumstances. So in this situation, we have 1/2 and 1/4. 1/2 plus 1/4 is just 3/4 of n, minus 5, greater than or equal to 9 plus 3/4 of n. And at this point, you should recognize that key characteristic that often makes an equation fall apart, which is that the variables, n, have the same coefficient, 3/4. Regardless of the side that I pick and the subtraction that I do, it's going to eliminate the n's and leave behind -5 greater than or equal to 9. And then you ask yourself the question, is -5 greater than or equal to 9? Well, obviously not. It's to the left of it on the number line. It's a negative number. It can't be greater than or equal to a positive. So this is a situation where we have no solution. This, very similar to the equation situation. We ended up with something that was patently false. The variables disappeared. There's no way to rationalize to yourself that -5 is greater than or equal to 9, so we leave this at no solution. It's a perfectly acceptable response, and in fact, it's the only response for this problem. This example is going to have a similar situation, but our interpretation of the result is going to be a little bit different. 5y minus 5 plus 2y less than 7y plus 7 minus 5. 5y and 2y makes 7y. 7 minus 5 makes 2. We see again that tried and true situation of the same coefficient in front of the variable. 7 y's will knock each other out, and we're left with -5 is less than 2. And you have to ask yourself the question, just like we did here with -5 and 9, is -5 less than 2? Yes, it is. Will it always be less than 2? It sure will. So here we have an infinite number of solutions. But this is not the same kind of infinite number of solutions that we had before. This is essentially shading all of the number line. Any value you pick for y is going to lead to something that is true. Because look back here. You're going to multiply 7 by y, and on the left you're going to take away 5, and on the right you're going to add 2. The right will always be larger, regardless of the type of number you pick. So making sure we understand that this is a absolutely true inequality all the time leads us to shade in the entire number line, the entirety of the number line. And this is different. Before, when we were answering the questions before, and maybe we were just shading in one direction. Sure, that was an infinite number of solutions. There's an infinite number of numbers that are larger than 0. But that's a different level of infinity, if we want to say it that way, than what we're going to get out of this one. We're getting shading in both directions, numbers of all type, versus only having half of the number line shaded.